Okay, so we're going to move on today, and we're still looking at statistical distributions. We've looked at discrete random variables, the binomial distribution, and now we're just going to look further at the binomial. We're going to look at cumulative probabilities. We're going to look at cumulative probabilities and how we can actually make good use of cumulative distribution tables and the cumulative distribution function on our calculators. So all of these together are just going to make working with binomial distribution questions a lot more efficient and swift. Okay, so whenever we want to, and we often want to, find the probability of a range of values. Now, we've looked at a few instances of this with the binomial distribution, and it's not too bad when we have a range of 1 or 2 values, or 1 or 2 outcomes, I should say. And it's not too bad when we have an event which is a combination of just 1 or 2 outcomes. So the probability that x is less than or equal to 1 is a combination of 2 outcomes. Probability x is equal to 0 and the probability that x is equal to 1. If our inequality covered more values, such as the probability x is less than or equal to 6, this starts to get complex. Yes, we know how to use the binomial function, but doing it 6 or 7 times within one particular question, well, that gets a bit tiresome. So we're going to look at 2 different methods that speed up this process for us. So let's consider this distribution. X follows a binomial of 10, 0.3. 10 trials, probability of success, 0.3. And we want to find the probability x is less than or equal to 3. One of our options is to make use of some probability distribution tables. Now, these are found in the formula books and they're widely available online, and this is what they look like. Every time somebody sees this for the first time, they're not sure exactly how to read these tables. So I'll quickly go through that with you. Firstly, the tables are separated into horizontal sections, and each of these refers to a different value of n. So, here's the section that we'll refer to if n equal to 5. Here's the section we'll refer to if n equal to 6, etc. Vertically, they're separated for different values of p, for different probabilities of success. So if we were working with the probability of success being 0.1, 10%, we'll refer to this column. 20%, this column. So we do need to track down exactly which column of values we should be referring to and working with. For our distribution, we firstly need to look for the horizontal section where n equals 10. So we'll just scroll through. We can ignore everything apart from this section where n equals 10. From there, we want p to equal 0.3. So it's going to go for the column 0.3. So we can ignore everything except for this column of 10 values. Now, looking at the left-hand side, we see x equals 0, 1, 2, 3, etc. We need to read across for the right row. The row that contains the 6 is going to give us the probability that x is less than or equal to 6. So from all of these values, the cross section is 0.9894. And that's how we use the tables. We track the n value, we track the value for p, and then we respond to the actual probability question we have. The probability that x is less than or equal to 6, we look at the row with 6. Less than or equal to 2, we'll look at the row with 2, and that will be 0.3828. Less than or equal to 9, if you see, these probabilities are only to 4 decimal places. Less than or equal to 9, the probability isn't 1, but if we have to round to 4 decimal places, it rounds to 1. Okay, so the tables, that's a very traditional way for us to track down some of these cumulative probabilities. You have a very powerful tool in front of you. That calculator can do a lot of this legwork for you. You may not even need to refer to the tables at all. The calculator that you have has the tables built in, and it can compute binomial cumulative probabilities. To get to the right menu, from the main calculator window, you're going to want to press Options, then statistics, then distributions. So this is the first time you're going to distributions, and from there we're going to pick binomial. You have a few options here. We're looking for binomial CD, binomial cumulative distribution. Okay, so now whenever you press this button, you're going to need to put in 4 different values, and those 4 values need to match the syntax: the minimum value you're interested in, comma, maximum value you're interested in, comma, the n value for the distribution, comma, and a p-value for the distribution. You'll need to put in those 4 things. So, for the probability that x is less than or equal to 6, the smallest number of successes I'm interested in is 0. I want all of the successes from 0 to 6. So my minimum is 0, my maximum is 6, n value is 10, p-value 0.3. Make sure the bracket closes, and you just need to press enter or execute. And there we have it. If you notice, it's the same answer that we would have got for the tables, except it's actually more accurate. We have a lot more decimal places involved. But rounding to 4 decimal places should be the standard in your statistics work, and that will be absolutely fine for an answer that you write down on paper and in your assessment. Okay, so it's on you to get familiar and used to using the calculator, probably the calculator more than the tables, but it is quite important that you know that these probabilities are also available on tables. As we move further in statistics, particularly for those of you who study further maths, and for all of you as we move into year 13, there are other tables that we're going to make use of. So now is as good a time as any for you to get used to referring to tables and pulling up these values. Okay, just going to run through a few more examples of how you might decipher some contextual phrases that you may come across, but I just want to reiterate something that I mentioned in a previous video, the one around discrete random variables. We should know that for every probability distribution, the sum of the probabilities is 1. All the probabilities add up to 1. Now this is very important, or very useful I should say, when it comes to rewriting a probability statement. Let's just see how that holds true in this example. The probability that x is greater than or equal to 3. That would be all of these probabilities. You can do some quick maths in your head. That's 0.9. I also could have found that out because 1 minus the probability that x is less than or equal to 2 will give me the same answer. This should make sense because the probability x is less than or equal to 2 plus the probability that x is greater than or equal to 3 should add up to 1. It's all the possible outcomes, all the possible probabilities. So a little bit of rearranging from there says that the probability that x is greater than or equal to 3 equals 1 minus the probability x is less than or equal to 2. Now, we're using a trivial example here. What if there were 20 different outcomes? Rather than adding up 19 of them, it makes more sense to subtract 1 of them. Rather than adding up 18 of them, it makes more sense to subtract 2 of them. Okay, another example here. This time, probability that x was greater than 3. I've mentioned before, and you should get into the habit of rewriting this using the values that are actually included in the statement. 3 is not to be included, so I might as well rewrite that as greater than or equal to 4, which includes the 4. Probability that x is greater than or equal to 4 is the same as 1 minus the probability x is less than or equal to 3. These two regions, these two shaded sections, will add up to 1. In general, and this is where I'm going, in general, the probability that x is greater than or equal to a number is going to equal 1 minus the probability x is less than or equal to 1 less than that number. Greater than or equal to 10, 1 minus less than or equal to 9. Greater than or equal to 50, 1 minus less than or equal to 49. This, in general, is a format that will come in very useful when we get to problem solving questions. Okay, let's move on. There are many worded questions that set up the scenario that we need to interpret and apply the binomial model to. Some of the phrases translate directly into probability statements, and we want to make sure we get the inequality in those probability statements exactly correct. The phrase no more than 6, that means 6 is the maximum that should be considered. We shouldn't be involving anything bigger than 6. No value that's more than 6 should be included. As a probability statement, that's the probability x is less than or equal to 6. It's already written in the format that I'm recommending. It has the equals to involved. We're talking about a number that we want to include. If we were going to find this probability from the tables, it's table ready. We can just go ahead and look it up in the tables. If we want to find this in our calculator, using the correct syntax, we would use BCD 0, 6, 20, 0.3. So type these in with me as we're going along so you get used to the format. And we'll get our answer straight away. The phrase fewer than 10. It must be fewer, it must be smaller, it must be less than 10. This means 10 is not actually included. So my initial probability statement is the probability that x is less than 10. We're going to rewrite that, and we rewrite it to use a number that is included. We're going to rewrite it as the probability that x is less than or equal to 9. Less than or equal to 9 is table ready. If you're using the tables, you can just go ahead and look it up. If you're using your calculator, this means we're interested in all of the values from 0 being the smallest possible value through to 9, and we're going to use n and p 20 and 0.3. For all of the examples here, we're going to use n and p of 20 and 0.3. At most 8. This means the maximum, the highest, the largest value should be 8. We're already talking about a value that we're interested in. So once again, this is table ready. You can just look it up in your calculator. 0.8 n and p. Alright, what about if we're told it was exactly 6? Well, that's an easy one to write out. It's the probability that x equals 6. We're definitely using a value that we're interested in and a value that's included because it's the only one that's included. In the tables, we can subtract 2 consecutive entries in the tables. We'll have the probability that x is less than or equal to 6, and from that we'll subtract the probability that x is less than or equal to 5. And the only probability we'll be left with is the probability that x equals 6. In the calculator, how we're going to type this, we'll go ahead and we'll type BCD. The smallest number we're interested in is 6. And the maximum number we're interested in is 6, because 6 is the only one we're actually interested in. So BCD 66 20 0.3. At least 4. So this is another way of saying that the smallest number we're interested in is 4. And all the other numbers, we want them to be larger than 4. So I'm going to go ahead and write this as the probability that x is greater than or equal to 4. This is not table ready. To look it up in the tables, we need to have a less than or equal to statement. And here is how we can rewrite this using a 1 minus. Greater than or equal to 4 is the same as 1 minus the probability x is less than or equal to 3. The less than or equal to 3 part we can look up in the tables and we'll subtract it away from 1. Okay, so a few more steps when working with the tables. In your calculator, smallest number I'm interested in is 4. The largest number I'm interested in is 20, since there were only 20 trials. So that's the maximum number of successes we can have. BCD, 4, 20, another 20 for the n, and a 0.3 for the p value. Greater than 5. So there's a subtle difference here. Greater than 5. the numbers I'm interested in must be bigger than 5. So that suggests that 5 is not included. I'm going to write this as the probability x is greater than 5. I'm going to rewrite it to make sure I'm writing in terms of a number I am including. The probability that x is greater than or equal to 6. Once again, this is not table ready. To use the tables, I'm going to need to rewrite this as 1 minus the probability x is less than or equal to 5. This can be looked up and subtracted away from 1. But if you're using your calculator, it's not that much different. BCD, minimum I'm interested in is 6, maximum I'm interested in is 20, n is 20, p is 0.3. And let's just look at one of these double-sided inequalities, which very similar techniques. The probability that we're between 4 and 7. 4 is inclusive, 7 is not. This is the inequality that I'll use to write that. But I'm going to rewrite it to contain values that are included. So the 4 is already included, but instead of 7, I'm going to use 6. If x is less than 7, 6 is going to be included. This form is not quite table ready, but I can do a calculation in the table as shown. But I really recommend that, especially at this point, we're using our calculators and we're able to just type this in very simply as the minimum I'm interested in is 4, the maximum I'm interested in is 6, n is 20, p is 0.3. If you learn how to use your calculator properly, it will save you so much computational work and effort. It will streamline the work that you're doing and actually enhance your assessment experience. You will be able to get through the working out stages of these questions quite quickly, meaning you can spend some more time interpreting the question in the first place and making sure that your final response makes sense in the context of the question.
Okay, so the last type of question that we want to look at is when we're working with cumulative frequencies, but there's an unknown lookup value. We don't know the lookup value. Okay, so let's have a quick read of this question. We have a spinner that's designed that the probability that it lands on red is 0.3. Now Jane is going to have 12 spins on this spinner. So the very first thing to do is to just write out the distribution. X follows a binomial, n is 12, p is 0.3. Part A just asks us to find a cumulative probability. Find the probability that Jane obtains at least 5 reds. So that's the probability that x is greater than or equal to 5. And this can go straight into your calculator. To 4 decimal places, we get 0.2763. In part B, it says that Jane wants to use the spinner for a class competition, and she wants the probability of winning a prize to be less than 5%. Each member of the class is going to have 12 spins, and the number of reds is going to be recorded. Now she wants to try and figure out how many reds should she set as the target number for you to win a prize. So she doesn't want to make it too easy by saying get 1 red, and neither does she want to make it too hard by saying get 12 or maybe 11 reds. So she wants the probability that it's greater than or equal to an unknown value to be less than 5%. Let's write that probability statement. Since we know that 1 minus the probability that x is less than or equal to r minus 1 is equivalent to x being greater than or equal to r, we can rewrite that, and we're going to try and make the less than probability the subject. So just some quick sensible rearranging. We end up with the probability that x is less than or equal to r minus 1 is greater than 0.95. So at this point we can either use the tables and we'll just scroll through the appropriate column looking for the first time that the probability goes above 95%. The value that we look up is going to be r minus 1. Or we can use some trial and improvement on our calculators, but once again the value we look up is going to be r minus 1. If you're using your calculator efficiently, you maybe could have started doing trial and improvement from the first line that we wrote here, just making sure that you're checking greater than or equal to values. But the tables, we have to have a less than or equal to statement, so we would have to do these first few steps. So either scanning through the tables or trial and improvement, we see that r minus 1 must equal 6. Which means that r must equal 7. So the number of reds that Jane should set for the class to win a prize should be 7. That guarantees there being a probability of winning which is less than 5%. She didn't want to set that probability too high. So okay, we've looked at a variety of ways that we can extend our knowledge and application of the binomial distribution using cumulative probabilities over a range and making sure that we can use both the tables and our calculators. And then we've just looked at some trickier questions using probability ranges with unknown values. So I'll leave you there to go away and put all of this into action with some practice questions.